Good afternoon, ladies and gentlemen, and welcome to the SAIEE Automation and Control Chapters webinar on resilient and secure energy infrastructure. Before we start, a few webinar considerations. Attendees are reminded to ensure the volume is turned up on your device. Ensure you have a stable internet connection. This will ensure the streaming and audio will run smoothly. Attendees can ask questions via the questions panel located within the GoToWebinar control panel. And by default, the control panel is located on the right-hand side of your screen. The chat function is reserved for webinar organizers and panelists to communicate with attendees. However, you will not be able to chat with each other, but we encourage you to ask questions. A recording of this webinar will be made available on the SAIEE YouTube channel, SAIEE TV. The QR code in the bottom left of your screen is for you to register to the SAIEE TV, and the recording of this webinar will be made available under the Automation and Control chapter playlist. A certificate of attendance will be issued a few days after this webinar. I'd like to introduce you now to our host for tonight, is Mr. Shandukani Vulandu, who's the chairperson of the Automation and Control chapter, and he is a senior research engineer at NTCSA Asset Management, Grid Modernization, and a registered professional engineer with over 13 years of experience in generation, distribution, and transmission. He serves as a SAIEE council member and, as I said, chairs the Automation Control chapter. Additionally, he's a volunteer member of the IEEE Standards Association, contributing to the recommended practice for leveraging machine learning and system aperture imaging and sensing. Shandukani is also a member of Seagrace Study Committee D2 and Working Group D2.64, which focuses on the application of artificial intelligence in cybersecurity defense for power systems. Over to you, Shandukani.
Thank you. I appreciate it, Mings. Welcome, colleagues. Yes, this is our host. We'll be hosting Khumutso Manyapetsa. Khumutso Manyapetsa is a professional engineer with a master's in engineering management and a chief engineer whose expertise is in control, automation, and OT cybersecurity. And he holds a bachelor in electrical and electronic engineering along with the cybersecurity certifications. With over a decade of experience in power utility and telecommunication, he is a specialist or specializes in the protection of SCADA system, substation automation, energy management, and DCS systems, focusing on cyber physical security for critical infrastructure. His skills include system design, commissioning, maintenance, IT, OT network convergence, and advanced cybersecurity architecture. He is dedicated to promoting best practices in OT cybersecurity amidst digital transformation challenges. With that, colleagues, I would like to welcome you, all the audience from various places, listening from various platforms. I would like to just give you one instruction just to say, for the comments, colleagues, should you have any comments, please put your comments on the chat. And should you have any questions along the presentation, please, we welcome you to put those questions on the question dialogue. Khumutso, you can take over from now. Thank you.
Khumutso, you're muted.
Oh, apologies. Thank you. I think I was having a bit of a challenge finding the audio. Yes, thank you very much for having me to this webinar. Let me just start. Okay, slide 2. Okay, the agenda is as follows. We'll talk, or we'll go today rather, we will be looking into this critical topic, that is the growing need for cybersecurity and operational resilience in energy systems. This is particularly relevant as information technology and operational technology are increasingly interconnecting. Our discussion will explore how secure architectural practices and advanced cyber defense tools, specifically the Industrial Demilitarized Zone and the Next-Generation Firewalls, which are now becoming critical enablers for secure IT/OT convergence, especially within the industrial control systems and our grid environments. So we'll just look at the cyber threats and vulnerabilities. I won't spend much there, as I've already did on the last webinar in November. Then we will look at the IT/OT and the convergence thereof. We check the firewalls, their evolution and how they operate. And then we will look at the next generation firewalls. How are they deployed? Then we will look at the industrial demilitarized zone, as well as some of the use cases that we have. Then we will conclude. So for digital transformation, our energy systems from power grids to manufacturing plants are undergoing a profound digital transformation. This shift brings about benefits that enable automation, remote monitoring, and optimized operations. However, this increased digitization and interconnectedness also creates new attack surfaces and vulnerabilities that hostile actors can exploit. I mean, the very systems designed for efficiency now face a wider array of sophisticated cyber threats. When coming to IT/OT convergence, the core of this evolution is the convergence of IT and OT. While IT focuses on enterprise data and OT on physical processes, their integration is vital for the future resilience and efficiency of our critical infrastructure. But this integration must be secure. So our focus today will focus on two key technologies that are central to securing this convergence. Next generation firewalls, offering advanced protection, and the Industrial Demilitarized Zone, which provides a secure buffer for data exchange. The unique industrial control system challenges. Unlike your traditional IT systems, industrial control systems face unique cybersecurity challenges. They are long operational lifespans, mean a reliance on legacy or obsolete systems, and many use proprietary protocols that weren't built with the modern cyber threats in mind. What is also important is that in OT, availability and safety are of paramount importance. This means that traditional IT security practices such as frequent patching and reboots are often not feasible or can even be disruptive. And then that makes these systems inherently more vulnerable. The key vulnerabilities, some of the specific vulnerabilities we see include the continued use of outdated systems, which lack modern security updates. I can tell you that there's somebody out there who's using Windows Server 2003 at this very moment. Communication protocols such as Modbus, DNP3, and other serial-based communication protocols, while they are foundational, they were designed for functionality and not really security, making them susceptible to exploitation. Even remote access solutions, if poorly configured, can become significant vulnerabilities. Also, the jump servers or remote access servers where people securely connect to the business, they themselves can create unintended pathways for attacks. So the very same jump server that is there for something good can be used to bring down the plant if not done correctly. And also we have this inadequate network segmentation can leave systems exposed. Common threats and attacks The threats are diverse, from disruptive ransomware, which is really big in the OT space. For example, the Colonial Pipeline in the USA incident caused a big havoc there, and ransom was paid actually for that. Excuse me. So now also we have advanced persistent threats that aim at long-term infiltration and supply chain attacks that compromise systems through trusted vendors. The cascading effects, it's vital to remember that an attack on the IT side can directly impact OT operations. The lines can really become blurry, and the consequences can be severe. Okay. To fully appreciate IT-OT convergence, we must first clearly define these two distinct domains. Information technology, or IT, it is what most of us are familiar with. Just about everything we do in a company is IT related. It's about managing data processing, storing, and ensuring its integrity, confidentiality, and availability. We can think of your enterprise networks, email systems, and business applications. Just about everything the company does resides on the IT side. When we come to operational technology, OT is fundamentally different. It's about controlling physical processes in the real world in real time. This includes systems such as PLC, or programmable logic controllers, SCADA, distributed control systems, or DCS, which are the backbone of our power grids, factories, water treatment plants, and so on. Here, the priority is always availability and safety. A momentary disruption can have severe real-world consequences. The physical system under control here that we are talking about, for instance, are your boilers or steam generators, temperatures, transformers, fluid storage tanks, motors and pumps, a big machinery. When we come to IT-OT convergence, IT-OT convergence is the strategic integration or interfacing of these two worlds, or perhaps maybe the three worlds, if you look at the picture there. It's about leveraging IT's data capabilities to optimize OT operations, which can all lead to greater efficiency and better decision making. However, it's vital to understand that this isn't about merging them into a single homogeneous system. Instead, it's about enabling secure interoperability. Both IT and OT retain their unique characteristics and priorities. Therefore, our cybersecurity strategies must be holistic and recognize and respect the distinct architectures, protocols, and compliance frameworks of each domain. For example, I think IT mostly uses ISO IC 27001 for IT, and I think worldwide we've seen the advertisement of IC 62443 for OT. Of course, there's other supporting standards too. One noteworthy point that can be made with reference to this diagram, if you just look at it, is that I did earlier mention that it's effectively the integration of three worlds and not two, because the first was the convergence of your OT cyber and the physical systems, and hence the term cyber physical systems. For us in the power utilities, this term is sometimes referred to as cyber physical power systems. So yeah, and it integrates operational technology systems such as the industrial control systems, the DCS, SCADA, energy management systems with the physical power infrastructure. This integration then allows real-time control, monitoring, and optimization of power systems across the generation, transmission, and distribution networks. So these cyber physical power systems, they leverage data from sensors and actuators for predictive and reactive maintenance, load focusing, and dynamic resource allocation. However, cyber physical power systems also introduce cyber security risks, which makes it important to protect your industrial control systems, such as your DCS, your SCADA, and other control systems against potential disruptions or compromises. Okay. Before getting into firewalls, perhaps let's briefly recap the fundamentals of the network communication and maybe the role of firewalls can perhaps be understood better. Understanding the open system interconnect model and the TCP/IP protocol stack can help us appreciate how firewalls operate at different levels. The open system interconnect, or OSI reference model, is a conceptual framework that standardizes the functions and protocols involved in network communication, whereas TCP/IP, or transmission control protocol, internet protocol, is a suite of protocols that provides the foundation for communication and data transfer on the internet and many other networks. It is often referred to as the Internet Protocol suite because it was initially developed for the internet. The OSI model is used as a reference or guideline to understand and compare network protocols and architectures for TCP/IP protocol suite. It provides common language and conceptual framework for discussing and analyzing various network technologies. It's just used to explain TCP/IP. Yeah. Okay. A firewall is a network security device that monitors incoming and outgoing network traffic and decides whether to allow or block the traffic based on a defined set of security rules. The firewalls serve as a primary line of defense in network security. They create a barrier between secured and controlled internal networks that can be trusted and untrusted outside network, the internet or any other network that is not under your control or administration. You can see the illustration that they exist in a variety of hardware form factors. Also, due to the proliferation of virtualization technology, firewalls also exist in software form as virtual appliances. Firewalls have evolved significantly. Initially, we had static packet filters, which were stateless and simply blocked traffic based on IP addresses and ports. Quite basic and easily bypassed with more sophisticated attacks. Then came proxy firewalls, which operate at the application layer, acting as intermediaries and deeply inspecting traffic. You can think of a web application firewall protecting web servers from specific application level attacks, such as SQL injection or cross-site scripting. Then another type of proxy firewall is number 3 there. It's circuit level proxies. They work at the session layer or layer 5 of the OSI model to manage connections, but still not inspecting the content of the packets in detail. Then a big leap took place with stateful firewalls. This type 4 remembers the state of a connection. It understands if a packet belongs to an established, legitimate communication session, making it far more effective at blocking unauthorized traffic and detecting anomalies such as incomplete TCP handshakes. Then number 5, deep packet inspection is an advanced method of analyzing network traffic that goes beyond traditional packet filtering. While basic firewalls inspect headers such as IP address and port numbers, deep packet inspection examines the actual payload of the packet. So it really unwraps everything and sees what's in there, and then it will wrap it up and send it where it's supposed to go if it complies to the policies that are set on it. Next generation firewalls represent the evolution necessary to combat today's sophisticated threats. They go far beyond what traditional firewalls could achieve, while retaining the stateful inspection capabilities. These next generation firewalls, they integrate a powerful intrusion prevention system, actively blocking known threats and suspicious activities. A defining feature is the application level awareness. Unlike older firewalls that might only see web traffic, next generation firewall can identify specific applications such as a particular SCADA protocol or a file sharing app and apply granular controls to it. This gives us much finer control over what applications can run on our networks. For instance, they also leverage external security intelligence, continuously updating their threat knowledge to stay ahead of new attacks. Also, what is important is that next generation firewalls offer full stack visibility and granular control, allowing deep inspection and policy enforcement across all layers of the network. So you can really go up all the protocol step and see what's in there. It includes the ability to decrypt and inspect encrypted traffic, such as your SSL TLS, which is a common way of threats to hide. The inclusion of intelligent security automation also means they can respond to threats autonomously, reducing manual intervention and response times. They are explicitly designed to overcome the limitations of their predecessors, offering adaptability in the changing threat landscape. Okay, when you're looking at the deployment types and considerations, the effectiveness of firewall depends not just on its capabilities, but also on how and where it's deployed. We typically deploy firewalls at the network boundaries or to segment internal networks into smaller, more manageable security zones. There are two primary deployment modes. The first one is a routed mode or layer 3. Here the firewall operates at the layer 3, acting almost the same way as a router does. It has distinct IP addresses on different network segments and routes traffic between them. This is the most common way or common approach for separating large network domains such as IT network and the OT network. This is to ensure clear policy enforcement at the routing boundary. So this is the most deployed instance that is out there. Then the rare one that we barely hear of is the transparent mode, also called layer 2 mode or bridge mode. Not sure why it was not called the switch mode as well, but it behaves as a layer 2. It's almost like it's a switch. It allows the firewall to sit in line within an existing network segment without being visible as a router. It inspects traffic without changing IP addresses. This is useful for aiding security controls within an existing VLAN or segment, especially in OT where IP addressing can be highly disruptive. And to address this long issue, some people always say firewalls are unable to inspect intra or same VLAN traffic because it doesn't need to go through the firewall. But if you deploy it as a layer 2 or bridge mode or transparent mode, suddenly now you can inspect same VLAN traffic as well. So this is one of the ways if you really wanted to see what's happening in the same VLAN, then you can deploy a firewall as a transparent mode or bridge mode. So these type of deployments can be seen at various levels. For instance, at the application level, proxy firewall strategically placed at, for example, in the Purdue model level 3, or even within the industrial DMZ level 3.5, which is level 3.4, I mean. And then this can provide the critical security layer. So I didn't mention much about the Purdue model, but the higher you go on the OT level on the Purdue model, the more stringent you can become in applying this as real time, especially at level 3.5. There's not much of real time issues. You don't control the plant from the IT side. Okay. Now we can move to the Industrial Demilitarized Zone, or IDMZ. This is a truly critical architectural component for achieving secure IT-OT integration. Its fundamental role is to provide a highly secure buffer, effectively segregating the IT and OT networks. The Industrial DMZ acts as a neutral zone, ensuring that even if one side is compromised, the other remains isolated. And this can then mitigate the risk of lateral movement or threat. Its core function includes rigorous network segmentation using firewalls. There's also networks there, so you can have switches, thereby having VLANs. You can have a variety of access control lists to create strict boundaries. It also provides data validation and filtering. It can have specialized proxies, inspect and sanitize data to ensure only legitimate information can cross this boundary. So the Industrial DMZ enables secure remote access to tools such as remote desktop gateway services, often serving as what we commonly refer to as jump servers, allows authorized personnel to connect to OT systems. However, it's vital to highlight that these jump servers themselves must be exceptionally well secured with strong authentication, strict access policies, and continuous monitoring, as they present a high value target for attackers attempting to breach the IT-OT divide. It almost sounds like a cliche what I'm saying, but in reality, some of these jump servers are just left, they are run to failure. No one checks the logs. Anything can happen there, especially for plants where you've got these mechanical systems. A lot of control system optimization is done there, and sometimes it's possible that remote access is provided, but you find there's no monitoring being done. So it's very important that the habit needs to change. This must be monitored. Also, the next generation firewalls again enhance the industrial demilitarized zone capability placed within this IDMS. They provide deep visibility into traffic flows. They can also enforce granular policies on data movement and also perform this deep packet inspection to OT protocols. Can detect anomalies that traditional firewalls would most likely miss. So effective industrial demilitarized zone design must also adhere to principles such as layered security, automation for seamless integration, and strict alignment with industry standards such as your IC 62443. Yeah. Okay. So if we look at the deployment cases, while the specific deployment use cases, sorry, let me just say, okay, let me just say, okay, we look at the strategic deployment. One common use case is secure data history and transfer. Operational data from the OT side needs to go to IT for analysis and reporting. But generally, we cannot allow direct connections. So that is where the industrial demilitarized zone acts as that secure intermediary. And the reason data is needed on the IT side, and the one reason more than anything is that all the users are sitting there. And even if you have the historian, the interface is always on the IT side. And this allows users to see their plans from a variety of locations, at home, in the office, and also it releases the respective control systems. Some of the control systems are limited in the number of people who can, the sessions that you can handle per plant. You might find one can only afford 10. So it means if there's a disturbance, a trip, only 10 people can use those workstations. The rest have nowhere to go. This is where the historian comes in. They can sit in their offices and do anything they want to do. If it's an investigation, they can do that. This is one good way of doing it. And similarly for things such as patch management, this industrial demilitarized zone can provide a safe way to deliver vital software updates to OT devices, which is critical for security, but must be done carefully to avoid disruption. And if there's any critical patches that need to be done, normally these are done during outages. Sometimes you have a long outage of maybe say over 100 days. So although even if you still have that, the administrators are always wary of doing that because you can cause damage such that the 100 days just feels like 5 days, and it will be a problem when it's time to bring back the plant. For remote, sometimes there is the need for remote vendor or internal maintenance remotely. There are cases where there has been in the past maintenance agreements where the OEMs could every now and then do remote maintenance, and in your plants, your plants such as say power plants, quite often you need to do optimization of your controls, loop tuning and all that. Sometimes it can be done remotely. It's not to say somebody is sitting somewhere far or something. They are still coming through these access servers by the demilitarized zone. They just need supervision. Yeah. So the industrial demilitarized zone needs to ensure that this access is tightly controlled, authenticated, and logged to minimize the risk of unauthorized entry or malicious activity. You need to always remember that people who are maybe doing crime are not just external people. Even our very own employees, the insiders, are a problem. So it then shows the importance of having some form of remote or logging, or the ability to always see what is happening and audit, sorry, these systems. The Industrial Demilitarized Zone can also facilitate centralized logging and monitoring, which is important if you want to do this integration. Also to allow your security teams or admins to have visibility on these OT events through a secure channel. To maybe you might want to integrate it into a platform. If you don't have, if your current control systems are unable to accommodate more signals for security, then you might need another different system such as your SIM to help with logging security logs. And for application integration between specific IT and OT applications, the Historian is a classic example. The application that the users use always resides on the user's laptop, even though it's an OT application. And this can happen through the IDMZS by ensuring that these critical data exchanges are secured and validated. Finally, services such as your network time protocol, domain name system for OT also benefit from secure filtered access via the Industrial Demilitarized Zone. However, I'm not sure what DNS is required for from the IT side. Normally, we just use private DNS, but there's a possibility for that for big OT environments. Maybe a utility WAN might require this. These use cases highlight the versatility and necessity of the Industrial Demilitarized Zone in real world converged environments. So to look at the deployment use cases from some of the ESCOM plants, there was a paper presented last year at PAC World, implementation of substation automation in ESCOM generation division with focus on monitoring and control of substation electrical reticulation. This is also one of the examples of how a demilitarized zone is utilized. So here you have a substation, electrical. They have their own system. Typically, electrical systems in power plants, you find they don't have, their systems are maybe too old, not digitized enough. But once you now have some sort of substation automation systems done, now there's a need to remotely see the plant. And in a power plant, typically this is controlled through the control and instrumentation side. They will have the big historian that can see the entire plant. But now if they need to interconnect with electrical system, because the CNI people in charge of the DCS are not in control of this, this is the opportune time when you connect, you just put a firewall there, and then you can serve the data to your users who are primarily at the enterprise side. And this is a convergence in action, and it brings about problems, wars between your OT people and IT people. You can just imagine, this happens all the time, that the historian application sometimes can fail. And when it fails, the question is, whose problem is it? So at face value, nobody knows, but whoever owns the server is always blamed. So what typically will happen, the OT guy, yes, there will be arguments, but he'll go here. If he comes here and he can see the plant, normally then he needs to hand over to the IT person to say, look, my system is working from here. The reason why it's not happening here, it could be anything in between here. But yeah, it's always a painful one. And I think it stresses why the word collaboration is always mentioned, because it's through the pains of these wars. So yeah, this is an example of one of the power plants. I think there could be several of them who are deploying this. Okay. All right, this is an example, one example Let me see. This is an example of, this is also an ESCOM initiative. This is ESCOM's Remote Monitoring and Diagnostic Center, or RMDC. Here they can monitor the entire plant. So they process data from the various DCS systems in power stations. And each power station will have a DCS, and then will also have, let me see, each power station will have a DCS, and then from that DCS you will have a historian network that interfaces with that DCS. Because that historian network and the DCS belongs to one person, typically just putting a firewall in between is sufficient, because it's the same network, it's trusted both ways. It's just that the other one is more diagnostic. So this is the perspective from RMDC side, how they collect. They come in with their own collector, so my pointer here, collector machines. They interconnect with the historian in the particular power station and pull it, and I can't seem to move the pointer, and aggregate it to their systems where they can see the entire plant. So this was done, I think the first rollout was done around, or the first iteration of this type of process was around before 2010. So you can imagine that power plants have been having historians for many years, while certain parts are struggling, especially the substations. This information is freely available through the use of open source intelligence, and you can find it here. They probably mention the history of how that came about. So you can see at that time you could do things such as data visualization, condition monitoring, depending on how they set it. They are saying they could do predictive monitoring. They can check the performance of your thermal plant, advanced alarming. Yeah, that one they did. They tried to duplicate the operating centers of each power station. What they do is they tend to set alarms at lower values than the real one. Even an individual at home, if you're working in a particular power station, you have the ability to do as you see fit on your laptop, design your own custom analytics and reports. If you like using the product, then there's a way to feed this data to the corporate side of things. So this is just a nice example of showing that the historians, they've been there for such a long time, and they are the ones that have really shown what type of convergence, or how convergence will look like, especially for plants that have been air-gapped for too long. Okay, let me see. Okay, to conclude, it is clear that the journey towards secure IT/OT convergence is multi-faceted. It requires not just technology, but also significant organizational shifts. A primary challenge is bringing the traditional silos between IT and OT teams, and this requires fostering deep collaboration through cross-functional teams, mutual training, and aligning certain priorities that are common to build a truly cohesive defensive strategy for the organization. We need to adopt a holistic IT/OT security approach. This means understanding and respecting the unique operational and security requirements of both domains. Applying an IT-centric solution directly to OT often fails due to the critical nature of their availability and safety in industrial processes, and just knowing that OT is just not the network alone, it's controlling physical systems out there, as I've mentioned in the beginning. Also, we must align with specific standards such as IEC 62443, and either you meet the minimum requirements, or you don't need to align if you can do better than what it's asking for. The power lies in defense in depth. I think this will always be there no matter what frameworks come in, because it's not prescriptive, saying exactly what to do. As we have seen also, next generation firewalls are powerful, but they are most effective when integrated into a layered security architecture that includes solutions such as your network intrusion detection systems, devices such as your network access controllers, security information and event management, and so this layered approach can create a truly collaborative and robust environment for threat identification and response. So let's also note that the immense role, I think this normally we don't talk about it, the immense role of the powering, electrification, the powering of these cyber physical systems plays. I mean, you've got your physical systems at the plant, big electrical or mechanical systems. You've got your cyber systems, industrial control systems. All these devices need to be powered.
Yeah, Humuzo,
and also
you can conclude, Humuzo.
Yes, sir.
So that we can have that 14 minutes for the questions. Yeah, thanks.
Okay. All right. To conclude, I can say maybe finally, cybersecurity is not a one-time project. It's a continuous process. We must embrace security by design, security by default, and security by deployment, and commit to ongoing assessment and adaptation to stay ahead of the evolving threat landscape and keep the systems on. Thank you. I hope you will derive some value out of this.
Yeah, thank you, Humuzo. That was a wonderful presentation, and I believe even the audience, I'm sure they have lots of questions, and these systems, they're actually in various industries, in power station, generation, distribution, or power utilities, oil industry, or yeah. And colleagues, I just urge you to just post your questions, and Humuzo is here, can actually address all your questions. And if you have a comment, you can open the chat and put your comment there. I'll just go and check if there is any question. Okay, I see there's good day. How do I claim the CPD points for attending the webinar? Okay, just to answer on that one, to get the CPD points, I think Minx, she has already indicated that the CPD point will be accompanied with the certificate. So when you get your certificate, you'll get those CPD points.
Yes, if I may just step in here, Shadukani. So
yes.
EXA requires us to, after a webinar, only apply for CPD validation, which normally takes up to 6 weeks. So the certificate, the validation number will be circulated within the email body when we circulate the attendance certificate. So please just watch out for that. Everybody who has registered with your email address will receive the attendance certificate with the CPD validation number. Thank you.
Thank you. I don't see any questions being posted here. Minx, is it possible to allow the audience to unmute if they want to, or to raise their hand?
No, it's not, but I can just help you out here with the questions. We've got a question here from Banele Soni. who's asking any remote access software you can recommend for OT?
Yeah, Khumutso can come.
Okay. Let me see. Yes. I want. Okay. I can say yes. You can. What you can do is one of the secure ways to come in OT because of the divide. Your systems are on the OT side, so you want to control that. So what I can recommend is first you need to create a VPN tunnel between your IT system and your network. From there, you can use any remote access protocol of your choice, say remote desktop or VNC. Just make sure you harden it. The VPN type, it will depend on the type of firewall you have, because some of these clients are normally dependent on what firewall you are using. For instance, if you are using Cisco AnyConnect, it probably means the firewall that is allowing you to VPN there is a Cisco firewall. So sometimes, but I think there are certain open source protocols out there too.
Thank you, Khumutso. We have another question from Vanele asking, is IDS recommended on both firewalls?
Yes, you can, especially at the higher. In fact, I think any level, as long as you have a firewall, you can have an IDS to monitor what is happening. A firewall, if anything is being violated, it can take action. It's proposed by normally. So you can have an IDS inside the firewall. Normally, it's a module that is sometimes licensed. When you activate it, it means you probably have to pay something. So you can have an IDS. You can have even an intrusion prevention system on top of it.
Thank you, Khumutso. We've got a question here from Dietmar Markgraaf. He says, great talk. Thank you very much. Just for interest's sake, have you ever deployed unidirectional gateways instead of firewalls?
No, I have not done that myself. I think he said unidirectional firewalls or data darts. No, I have not done that. I know that. It's just that the problem that I have with them it's not really a problem. Is to say, if I now having a lot of data on the field, a lot of IoTs in the field, so there's a lot of data coming from the plant, and this plant needs to reach some data repository on the IT side, and quite often the protocol that is being used there is TCP. And with TCP, the problem is it requires bidirectional communication. If I take the historian and it sits on the OT side at very high level at the DMZ level 3.5, the bidirectional communication still happens between that server and the client's PC. So the problem is just that if you put unidirectional, that now causes one to, now you have to think of duplicating the server. And I'm not sure how it's going to work. But if it doesn't allow bidirectional direction, my only problem is how is TCP protocols going to be catered for? Because UDP, I don't think it really has a problem. You can just use one directional. Yeah, that's what I can say. But I have not used it myself. But I do have an understanding because of the air-gapped plant. So if you've been air-gapped for so long, sometimes you just want to now open up.
Thank you, Khumutso. We have a question from Sitoli Sipo, who's asking, there was a slide about your next generation firewalls where one of the capabilities was IDS included. Does this mean that organizations can rather implement these firewalls versus implementing a separate IDS solution, which is independent from the next generation firewalls?
Yes, yes, it's one of the options. You can use them because, for instance, if you're in a substation or a power station, you normally have one device or so that allows a router, for instance. A router is a firewall as well. Some routers you find you have to activate the firewall capability, then suddenly it's a router. So if you have, yeah, to be honest, I think, let me just say yes, you can leverage those. And if you like, you can even deploy them closer to where the switches are in between the trunks if you must. So that is one of the viable options too.
Thank you. We have a question here from our immediate past president, Mr. Pascal Motswasele. Good evening, Pascal. He's asking, is there a difference between an industrial firewall and a traditional IT firewall? Because the company he works for has given the mandate the provision telecoms to IT division, and they are putting the firewalls to connect the OT networks at a WAN level. So is there a difference between industrial firewall and traditional IT firewall?
Normally, the difference that I see is only in the hardware, is that most of the IT firewalls are mainly meant to operate in a nice, cooler environment, data center type, whereas maybe in the industrial side, you do not have such. But lately, I have not seen, I cannot say there's a difference because I've seen the same firewall that works in the IT being sitting on the OT side. Although there are some that appear to be different, but it's mainly because they are meant to operate in environmentally unfriendly areas. I mean, you can imagine if you use a normal standard firewall in a plant where there's a lot of dust, those firewalls might not be able to handle such dust accumulation, and it can cause some problem. But the only difference is mainly in the hardware, because nowadays any protocol, they can all learn any protocol.
Thank you. And then Pascal has asked the next question. Would you recommend that OT teams look into migrating from the old DNP3 and Modbus networks, and to what, assuming that would improve OT cybersecurity?
Yes, for me, if protocol is obsolete, to be honest, I'm not a fan of using obsolete protocols. Even when you hear the very OEM of those protocols has advocated for customers to move away. So I'm not a fan of it. DNP3, we've seen that there is a version of it that is IP based, and it's mostly used closer to the municipalities or smaller substations. I would recommend they use some of these protocols are still widely used, especially Modbus. There is an IP version. Have not checked if it's being evolving. I would say serial-based ones, yes, they must move to IP-based ones. Pulling data from the plant or the field, there is a lot of IoT protocols that are coming up. You can compare with those ones that are there and see whether is this current one, are they evolving? If they are not evolving, because I know it was on IP, both have IP equivalents. If they are not evolving, then I think they can rather look at the new IoT protocols.
Thank you,
and internet is there as well in the field too.
Okay, thank you. And we've got a question from Bruce Ricardo Thomas. He's saying, interesting talk. How are emerging technologies like AI and digital twins being used to improve resilience?
Okay, I have not seen it being used yet, but that holds a true benefit for your operators, in fact, the whole team, maintenance and engineering teams, because for quite a long time, you can't land the plant if it's live, and it takes forever for it to be on outage. And if it's on outage, you can't fiddle there. It might not come back normal. But with digital twins, you are now able to have some scenarios of the plant and learn from them. I have not used digital twins before. Because I work a lot with networks, I just emulate networks. So if I have a particular server running a certain application, I just try to emulate it somewhere else where there's no stress. If I make a mistake, I know I can rebuild it again. So from my side, I'm more familiar with emulation, and I think borrowing from it. I think with digital twins, you can do the similar scenarios, especially for your mechanical plants. Yeah, I think that is the best. But the one thing you can use immediately if you're in the networking field, definitely emulation is there. You just need a computing platform with enough CPU and RAM and storage.
Thank you. Our second last question we're going to answer. We have one from Pumotso Matiwa. From your experience, what are the key skill sets? My apologies. What are the key skill sets or competencies that teams need to successfully navigate OT/IT convergence? And how have you addressed the gap between traditional OT engineers and IT professionals in your organization or at Eskom?
Okay, I've not really worked in IT, but I've interacted a lot with the guys from IT. The one thing that needs to happen is people need to learn continuously. Every year or 2 years, people need to learn. Some of these solutions that are used can be tailor-made for either IT or OT. For instance, we all use Windows servers across the board. So what the IT guys know, surely the OT can learn. And to understand something faster, I think people need to get their hands on. First, you do certifications, go there, attend the classes. It's almost over 500 pages that you need to go through. Give yourself 3 months. Try to go and do the labs. That's experience. Do the practicals. Go to the plant. Also play around. This, for me, it's always the best way to learn, because both sets of solutions, sometimes they are different, but we are using the same similar tools, except for certain levels where you're about to combine with the physical equipment. Yeah, the life changes completely, because that's a completely different protocol that are used there. Instruments, there's actuators, it's mechanical. So that part I know it's very difficult for IT people, and also your OT guys. If they understand that part, they struggle to understand even the networks inside their own domain. So you'll find that one person is now dedicated for this, and the rest of the team finds themselves in the field. So I think sometimes, for me to bridge this, they just need to do these certifications, because they might be targeting IT, but there's applications for their network. I mean, IP addresses are everywhere. So yeah, I'm not sure if I'm answering it.
Thank you, Khomotso. I just want to say, before I ask our last question, the questions that we didn't get to, I will send to Khomotso to answer, and with your email address so he can respond directly. Our last questions from Meli Mtembu. Using VPN from local and remote station, which security implementation would you recommend between IPsec and TLS?
Okay, I have both, but IPsec is mostly preferred. I would say IPsec, we can use IPsec, but there's use cases for TLS as well. Actually for VPN, I'll stick with IPsec. Then number 2 will be TLS 1.2 and above.
Thank you, Khomotso. Over to you, Shandukani.
Yeah, thank you, Khumutso. I think this was an eye-opening, and yeah, the presentation was well delivered. I hope we gain knowledge. Yeah, colleagues, for the other presentation that can follow, I recommend that you join SAIEE. We do have a application form. We can send a link for you to register. And I think with that, I will say we have come to the end of this presentation or end of this webinar. And if you want to join my chapter, I'll recommend that you DM me, and then we can take it from there. The webinar has adjourned. Thank you.
Good.
Thank you. Bye-bye.